Welcome back to my complete Dart course for beginners and beyond. This video contains the 6th chapter of my course and I've decided to share this for free here on YouTube. And if you're serious about learning Dart, you should consider buying my full course on Udemy. This will include over 10 hours of content and comes with premium support as well as a complete reference ebook about Dart. And you can buy the full course for a discounted price by typing this URL in your browser. Okay, so let's get started. In this section, we will learn about collections in Dart, and you can think of collections as a group of values that belong together. And in Dart, there are three main types of collections: lists, sets, and maps. So in the first part of this section, we will learn about these collection types along with the most common operations that we can do with them. And we will also see how the type system and type inference work when we use them on collection types. After that, we will learn about collection if, collection for, and spreads, which are some special features of the Dart language that make it easier to work with collections. The material in this section is very valuable because collections are found everywhere in programming, and Flutter apps are no exception, because every time you need to show a list of items, you need to work with collections. Okay, so let's get started. In this lesson, we are going to learn about lists. Lists are also known as arrays in other programming languages, and they are used to represent a collection of values. For example, we can declare a list of cities as var cities equals, and then within square brackets, we can add some string literals. So for example, London, Paris, and Moscow, like this. So this is a list of string literals, and if we want, we can print cities, like this. And if we run this program, then on the console we get London, Paris, and Moscow. Now, let's suppose that we want to print a specific city on this list. To do that, we can add a pair of square brackets with the index of the item that we want to print. For example, to print the first item, we need to use index 0. And if we run this program again, on the console we get London. Likewise, to print the last item, we can use index 2. And if we run the program again, this time we will get Moscow. And the important thing to remember is that if you have a list of n items, you can only access them using the indexes from 0 to n-1. And that's because in Dart, indexes are 0 based, meaning that the first index starts from 0. As a proof of this, here we can try to use -1, and if we run this, we get a runtime exception telling us that the index must not be negative. And also we could try to set 3 as a subscript, and if we run now, we get another error saying that the index should be less than 3. So remember that when you use an index outside the valid range, you will get an exception. So it's important that you always use indexes within bounds. Okay, so we can use the subscript operator to read an individual item from the list, but we can also use it to change the value of one of the items. To do this, we can type cities, and then, for example, index 1 equals Rome, like this. And if we print the entire list of cities now and run the program, we see that the console shows London, Rome, and Moscow. And once again, if we print only the item at index 1, then we will get the updated value on the console. So this is how we access items by index. But if we want, we can also iterate through all the items in the list. To do this, we can use a so-called for loop. So here is how this works. We can type for and then var city in cities and then curly braces, and inside the loop we can print city, like this. And as we can see, this prints all the cities line by line. By the way, this looks different from the for loop that we have learned about in the previous section. And if we wanted to print all the cities using a conventional for loop, we would write something like this: for var I equals 0, I less than cities dot length, like this, and then I plus plus. And then inside the body, we could print cities with index I, like this. So this works with a temporary I variable that starts from 0 and increments at each iteration until it reaches the number of cities and exits the loop. In other words, the loop will be executed for I that goes from 0 to the number of cities minus 1. And inside the loop, we use the subscript operator to access the cities list by index. So these two loops do exactly the same thing. But as you can see, in this case, we need more code because we had to manually take care of updating the index. And Dart gives us a convenient way of doing exactly the same thing with a for in loop. Okay, so let's delete this and we can continue with an exercise. In this exercise, I'd like you to write a program that defines this list of integers and prints the sum of all the values in the list. So you can pause the video and try this by yourself. Next, we'll solve it together. Okay, so here's the solution. To start off, we can declare a values variable that will hold a list with all these values: 1, 3, 5, 7, and 9. Then we can write a for loop to iterate through each item. So we can type for var value in values. And since we want to calculate the sum, we need a variable that we can use to add up all the items. So here we can add a var sum equals 0. And then inside the loop, we can type sum plus equals value, like this. And at the end of the loop, we can print sum. And if we run this program, we can see that the result is 25. Okay, so let's continue on the next lesson. It's now time to learn some basic operations that we can do with lists. To do that, let's get back to our list of cities, and to check the number of items in this list, we can print cities.length, like this, and this will print 3. To check if a list is empty, we can type cities.isEmpty. And we can also type is not empty to check if the list is not empty. For example, we could call this on an empty list literal, like this. And if we run this program, we can see that the output is true and false. Next, let's see how we can get the first and last item on the list. So here we can print cities.first. And if we run this, our program will print London. Likewise, if we print cities.last and run this, then we will get Moscow. By the way, if our list is empty, then it doesn't have a first or last value. As a proof of this, here we could print an empty list literal dot first. And if we run this program, then the console output shows an error that says bad state, no element. So just like we can't use the subscript operator with an index out of bounds, it's invalid to call first or last on an empty list. Okay, so we can clear this. And next, we want to look at a few methods that we can use to modify the contents of the list. To add an item to this list, we can type cities.add Tokyo, like this. And if we print our cities and run this program, we can see that the output says London, Paris, Moscow, and Tokyo at the end. However, if we want to insert an item at a specific position on the list, we need to use a different method called insert. And insert takes two arguments, where the first one is the position where we want to add the item, and the second is the item itself. And if we run this now, we can see that Tokyo appears in the second position. And as a reminder, the second position corresponds to the index 1. And that's because indexes start from 0. And just like we can insert values, we can remove an item by typing cities.removeAt. And then, for example, index number 2. And if we run this program, we can see that Moscow no longer appears on the list. And if we want, we can even clear all the contents in the list by typing cities.clear, like this. And if we print this, the output will show an empty list. Next, let's talk about finding an item in the list. In order to check if a list contains a certain value, we can type cities.contains, and then within single quotes, Moscow, like this. And this expression will be true or false depending on whether this item is on the list. So this is useful, but how can we find the index of a given value in our list? To do that, we can type cities.indexOf and then Moscow, like this. And if we run this, the console log prints 2, which is the index of Moscow in this list. But if we try to find the index of Beijing, which is not in this list, we get -1. In summary, these are the most common operations that we can use to work with lists. And if we type cities dot, we can see many additional methods that we can use to work with lists, and we will cover some of these in detail later on. Okay, so let's continue on the next lesson. Up until now, we have been working with list literals, and we have declared list variables with the var keyword. But as a reminder, we can always write the type explicitly when we declare a variable. For example, here we could declare the cities variable as a list with a capital L. But if we want, we can be even more specific, because cities should be a list of strings. And as it stands, here we can add the number 10, and Dart seems happy with this. But 10 is not a city, and we shouldn't be able to add anything that is not a string to this list. To fix this, we can add a pair of angular brackets after the type name, and inside we can type string, like this. And now we can see that Dart complains and tells us that the element type int can't be assigned to the list type string. And to make Dart happy, we have to remove this value from the list. Okay, so this is better, but in general, we prefer to declare variables with var, final, and const, and let Dart infer the type for us. So is there a way to use this syntax, but still tell Dart that we only want strings inside this list? The answer is yes, and to do this, we can add some angular brackets right before the list literal and type in string like this. And now that we've made this change, here we could try to add the number 10 once again, and as you can see, this error appears again, because Dart helps us to make sure that this is a list of strings, and our code is only valid if we remove this. So what we have just done is to add a type annotation to a list literal. Type annotations are optional in Dart, but it's important to know that they exist, because you are likely to encounter them when you read Dart code from other developers, and they also help you to write safer code. Okay, so let's continue on the next lesson. In this lesson, I want to talk again about var, final, and const, because they don't behave exactly in the way you may expect when working with lists. Up until now, we have declared lists using var, but if we want this variable to be set only once, we can declare it as final, like this. And as a result, you are not allowed to write cities equals Venice, like this. In fact, Dart tells us that the final variable cities can be set only once. However, here we can write cities of index 1 equals Venice, like this. And you may be surprised to see that this code is valid. After all, we have declared this variable as final, so it seems strange that we are able to change it. So just keep in mind that using final will stop you from assigning this variable after it has been initialized, but you are still allowed to modify its contents, like this. So this is how final works with lists. But what about const? Well, it turns out that you can declare this variable as const if you want to, because this list literal is a compile time constant. And as you can see, this line now is invalid, and the error says constant variables can't be assigned a value. So this error is expected. On the other hand, the compiler doesn't complain about this line, and it seems that we can modify the contents of a const list variable. So let's comment out this line, which is invalid, and try to run this code. And we can see that Dart prints this error that says unsupported operation indexed set. So this makes sense, but it's a bit strange that Dart can only catch this error at runtime, and it would be better if we could generate a compile time error instead. Okay, so let's do a wrap up and try to clear things up. When you use lists or any kind of collection, you can use var, final, and const, so that Dart can infer the type for you. And as you would expect, final and const stop you from setting a variable more than once. But you can still modify the contents of the variable itself if it is final. On the other hand, attempting this with a const variable will produce an error at runtime. By the way, if this all seems a bit confusing, don't worry, we will see more examples of var, final, and const as we make progress. Okay, so let's continue on the next lesson. In this lesson, we are going to talk about sets. In Dart, sets and lists are collection types, but there is one fundamental difference between them, and that is that lists can contain the same item more than once and sets can't. In other words, sets are collections of unique values, whereas lists can contain duplicate values. So how do we declare a set in Dart? Well, here we can type var countries and then equals to open and close curly braces, and inside them we can type Italy, UK, and Russia, like this. So when we declare a set literal, we should use curly braces, and when we declare a list literal, we should use square brackets. Okay, so let's remove this list and focus on the countries set. And if you remember, when we talked about lists, we said that we can access items by index by using the subscript operator. However, the subscript operator does not exist when using sets. So if we try to type countries of 0, we are going to get an error that says the subscript operator isn't defined for the type set string. Instead, if we want to get an element at a certain position, we need to type countries.element at, and then we can pass the index like this. Okay, so what kind of things can we do with sets? Just like with lists, we can add a value and type add Iceland, like this. And if we print countries and run this program, we can see that we have a set with Iceland at the end. However, if we try to add Italy, which is an item that is already in the set, then we can see that Italy appears only once, and that's because sets only contain unique items. Also, we can remove an item by typing countries.remove Italy, like this. And if we try to remove an item that doesn't exist, the contents of the set remain unchanged. By the way, just like with lists, we can get the first and last item inside the set, as well as the length. And we can also check if a set contains a certain item, like this. Next, let's learn about some interesting operations that we can do with sets, but not with lists. And these operations are union, intersection, and difference. To show you how they work, let me rename this set to EU countries, as I want it to represent the countries in Europe, and here we can declare a var Asian countries equals, and then we can create a set that contains India, China, and Russia, like this. And then we can print EU countries.union with Asian countries. And if we run this program, we can see that the output is a set that contains the union of all these countries. And Russia is only included once, even though it belongs to both sets. Then we can print the intersection of these sets, and this is a set that contains only Russia. And we can also print the difference between these two sets, and this produces a set with the items that are on the first set but not on the second. In summary, sets are a type of collection that is similar to lists. Just like with lists, you can iterate on a set using a for-in loop. But the main difference is that sets only contain unique items, and as a result, they offer union, intersection, and difference methods, and these can be quite useful in many cases. Okay, so let's do an exercise. In this exercise, I'd like you to solve this problem about sets. Given two integer sets a and b, write a program to calculate the set of the elements that belong to either a or b, but not both. For example, given the following sets, the program should print 1 and 5. Then calculate and print the sum of all the items in the resulting set. So you can pause the video here and try to write this program. Okay, so let's see how to solve this. To get started, here we have our two sets, and we could calculate their union by typing final C equals A.union with B. And this will give us a new set which contains all the items. But remember that we don't want the items that belong to both sets. In other words, we don't want the items that belong to the intersection of A and B. So to do this, here we can take the difference of A.intersection with B, like this. And if we print C and we run this program, the console output shows 1 and 5. So this solves the first part of our problem. Next, we need to calculate the sum of all the values in the resulting set. To do that, we can use a for loop and type for var value in C. And then, like we did before, we could add a var sum equals 0 variable, and inside the loop we could type sum plus equals value, like this. And then we could print the sum at the end. And if we run the program now, we can see that it prints 6, which is the sum of these two values. Okay, so this completes our overview about sets. And when you work with collections, most of the time you'll be using lists. However, there are certain use cases where you may need to work with collections of unique values. And in these cases, it's much easier to use sets. So keep in mind that sets are supported in Dart and use them if you need them. Okay, so let's continue on the next lesson. In this lesson, we are going to learn about maps. Maps are an important type of collection that is often used in many programs, and maps are also called dictionaries in other programming languages. So what is a map? A map is a data type that we can use to store a collection of key value pairs. For example, here are some key value pairs that represent my name, age, and height. So let me show you how to define a map that contains these key value pairs. So over here we can type var person equals and then a pair of curly braces, and inside here we can add all our key value pairs. So we can type name within single quotes and then colon and then Andrea like this, comma, and then on the next line age colon 36 and then height 1.84 like this. So what we have here is a map literal that holds these three key value pairs. And the important thing here is that these keys should be unique. And if we try to add another age key with a value of 40, then Dartpad tells us that two keys in a map literal shouldn't be equal. And while this is not an error in itself, it only makes sense to have unique keys. So this is how we can define a map. And notice how here I've defined all the keys as string literals, while the values are a mix of different types. And because we've declared this variable with var, we can use any types we want for the keys and values on this map, and Dart will infer the map type for us. However, if we want, we can explicitly tell Dart what types we want to use. To do this, we can replace this var with map with a capital M, and then within angular brackets, string, comma, dynamic, where string is the type of our keys and dynamic is the type of our values. And the reason this needs to be dynamic is that all these values have different types. So let's see what happens if we change this to string, like this. As we can see, we get two errors telling us that the element type int can't be assigned to the map value type string. And the same happens if we try to use double instead of string over here. So if we want to have values of different types, then we need to use dynamic. By the way, when we talked about lists, we have seen another way of defining type annotations on collection literals. And we can do the same here. So we can declare our map with var, just like we did before, and then before the curly braces, we can add some angular brackets and specify the types string and dynamic, like this. And this will tell Dart exactly what types we want to use. So the takeaway here is that whether we use lists, sets, or maps, type annotations work exactly in the same way. Strictly speaking, you don't have to add type annotations to your programs, but they help make your code safer by adding some constraints on the types that you use. And throughout this course, I'll always point out when it's a good idea to add type annotations and when it's okay to leave them out. Okay, so let's get back on track and see how to use maps. To access the values inside this map, we can use square brackets. So here we can type var name equals person, and then within square brackets, we can use the name key, like this, and then we can print name. And if we run this program, we can see that it prints Andrea. So what we have done here is to use the subscript operator to get the value that corresponds to the name key. And we have assigned this value to a new variable called name. Okay, so we have seen how to read values from the map. But what about setting new values? To set a value for a specific key, we can type person with age equals 37. And if we print person after this and we run the program, we can see that the age is now 37 inside the map. And if we want, we can also set new keys. For example, here I could type person and then within square brackets likes pizza, equals true. And if we run this program now, we can see this new key value pair on the console. Okay, so before we continue, I want to focus on this line. So let me delete some old code from here and here. And if you look at this line, can you guess what is the type of this name variable? Is it a string because this value is a string? Or is it dynamic because dynamic is the type annotation of the values in this map? I'll let you think about this for a second and we can continue on the next lesson. In the last lesson, we ended with a question, and that is, what is the type of the name variable that we declared here? Well, one way to find out is to see what methods are available for use with this variable. So here we can type name dot, and we can see that we get a list of only 4 methods, and this doesn't include all the methods that are available when we work with strings. And that's because at compile time, Dart can't work out that this variable really is a string. So in this kind of situation, we need to give Dart a little help so that it can infer the type that we want. And the best way to do that is to use a special operator called as. So here we can type as string like this. And now if we type name dot, we have access to all the methods of the string type. And just to be clear, there are other ways of telling Dart that this is a string. For example, by declaring the type explicitly, like this, so that you don't need the as operator. But I do recommend that you use this syntax instead. And I can't explain this in enough detail right now, but we'll get back to this later on when we talk about classes. So the takeaway of this lesson is that if you declare a map that has dynamic values and you need to assign values to variables that are not dynamic so that you can access their methods, then you should use the as operator followed by the type that you want. Okay, so let's get back on track and continue on the next lesson. In the previous lessons, we have seen how to access values by key inside a map. So what happens if we try to access a key that doesn't exist? For example, here we could type var weight equals person, and then within square brackets, weight. And then we can print weight like this. And if we run this program, we get null on the console. So what is null? Null is a very special keyword in Dart, and it means that there is no value. So in this case, the program prints null because there is no weight key on this map. So we will talk more in detail about null later on because it is an important concept. But for now, the important thing to remember is that whenever you try to get a value for a key that doesn't exist, you will get null. And if you want, you can write a condition to check if a value is null. For example, here you could type if weight equals null, then print no value, else print weight, like this. And if you run this program, you can see that it prints no value. So keep in mind that variables and expressions can be null and that you can check if something is null like this. Okay, so let me clean up some of this code and we can continue on the next lesson. Now that we know how to define a map, let's see how we can iterate through its key value pairs. And as we have learned, we can use a for in loop to iterate through a collection. So here we could try to type for var item in person, like this. But as we can see, here we get an error telling us that the type map string dynamic used in the for loop must implement iterable. So this message is not entirely clear at this stage because we don't know what an iterable is. So let's clarify this. An iterable is a collection of items that can be accessed sequentially. According to this definition, both lists and sets are iterables, and so we can iterate through a list or a set with a for in loop. However, a map is a collection of key value pairs, and that in itself is not an iterable. To get around this, here we can type person.keys, like this. And this will give us an iterable or a collection of all the keys in this map. So if we want to iterate through the keys, we can type for var key in person.keys and then print key, like this. And if we run this program, it will print all the keys like this. But what if we want to print all the values? Well, one way of doing this is to print person, and then we can use key as a subscript. And we already know that this key exists because we are iterating through the keys themselves. So if we run this, we get all the values line by line. But if we only want to print the values and we don't care about the keys, there is a simpler way. And that is to type for var value in person dot values and then print value like this. So depending on whether you need to iterate through the keys or the values, you can use a for in loop like this. Not only that, but there is also a third way to iterate through a map. So let me show you how. Here we can type for var entry in person dot entries like this. And if we type entry dot, then here we can get access to both the key and the value. And we can use this to print the entry dot key and the entry dot value like this. And if we run this program now, we can see the first three values which are printed by the first loop. Then we can see these other values which are printed by the second loop. And at the end, we get both the keys and the values which are printed by the last loop. And the takeaway from this lesson is that there are different ways of iterating through a map. Okay, so let's continue with an exercise. Here is a new exercise for you. Given the following map of pizza prices, write a program to calculate the total for a given order. For example, given the following order, the program should print total $13. Note that if a pizza is not on the menu, the program should print something like this. Pineapple pizza is not on the menu. So take some time to solve this program and then I'll show you the solution. Okay, so let's do this together. And what we have here is a map of pizza prices and a list containing our order. So in order to calculate the total, we should iterate through all the items in the order and use them as keys in order to get the corresponding price from this map. And we will also need a variable that we can use to calculate the total order price. So let's write this. And over here, we can type var total equals 0.0. And then for var item in order. And then we can type final price equals pizza prices with item like this. And then we need to check if the price is not null, because it's possible that we are trying to order a pizza that is not on the menu. So here we can type if price is not null like this. And if it's not null, we can update total and say plus equals price like this, else print, and then within single quotes, $item pizza is not on the menu like this. And at the end, after the for loop, we can print total. And here we need to escape the dollar symbol and then use it again to interpolate the total variable. And now we can run this program and we can see that the console prints a total of $30 for this order. And now we could try to add a pineapple pizza like this. And if we run this again, then the program tells us that the pineapple pizza is not on the menu. So this was a good example of how we can use maps, lists, and for loops to calculate the total for a pizza order. And as you can see, our programs are becoming more and more interesting as we make progress. So let's continue on the next lesson. Now that we know how to work with maps, lists, and sets, we can see how to nest them together to create more complex data structures. For example, suppose that we have a list of restaurants where each restaurant has a name, cuisine, and a list of ratings. So how can we represent data like this using collections in Dart? Well, in this case, we could use a list of maps. So let's see how to declare this in Dart. Over here, we can type var restaurants equals and then square brackets because the top level collection is a list. And then inside the brackets, we can add one map for each restaurant. So here we can type some curly braces like this. And to speed things up, I'm going to paste the key value pairs that correspond to this data. And since the ratings are a collection of values, here I've added them as a list literal. And then we need to add the 2 remaining restaurants. So here we can add a comma, and again, to speed things up, I'm just going to paste them in here. And now that we have this, we could iterate through this list with a for in loop. So here we can type for var restaurant in restaurants. And on each iteration of the loop, we can print restaurant like this. And then we can run this program. And as we can see, all the restaurants are printed on the console. So this is an example of how we can nest multiple collections to represent complex data structures. And as you can see, here we have a list inside a map, inside a list. And we can use the usual control flow statements to work with these collections. Okay, so let's do an exercise using this data. In this exercise, I'd like you to write a program that works with nested collections. So given the following list of restaurants, write a program that calculates the average rating score for each restaurant and adds it as an average rating key value pair for that restaurant. You can use the following code as a starting point. And just as a reminder, here we are using the as operator to make sure that the type of this ratings variable will be a list of double. So you can pause the video here and try to solve this program. Okay, so let's solve this together. First of all, we need to work out how to calculate the average rating for a restaurant. And the average rating is equal to the sum of all the ratings and divided by the number of ratings. So let's write the code for this. And here we can type var total equals 0.0 and then for var rating in ratings. And then inside the loop, total plus equal rating, like this. And then outside the loop, we can type final average rating equals total divided by ratings dot length, like this. And here we can uncomment this line and write restaurant with key average rating equals average rating, like this. And just to make sure that our program works, here we can print the restaurant and then we can run this code. And on the console, we can see that each restaurant now has an average rating key value pair. So this is how we can update a map that is nested inside the list. So let's continue on the next lesson. It's now time to introduce some new statements and operators that make it easier to work with collections. These statements are known as collection if, collection for, and spreads. So let's see how they work by starting with an example. Here we can type final colors equals, and then within single quotes, gray and brown. So this is a list of strings representing some colors, and then we can add 2 Boolean variables. The first one is const add blue equals false, and the second one is const add red equals true. So what we want to do is to add some more items to this list if these variables are true. To do that, we can type if add blue, then colors dot add blue, and we can also copy paste these 3 lines, and here we can say if add red, then colors dot add red, and then at the end of the program we can print colors like this. And if we run the program, we can see that the console shows gray, brown, and red. So this list contains red because add red is true, but not blue because add blue is false. So if we want, we can write code like this to add some values to a collection only if certain conditions are true. However, Dart has a special feature called collection if that makes this task a lot simpler. To see how this works, we can declare a new variable called colors2, and we can initialize it with square brackets. And then inside here we can type gray and brown like this. And inside the collection we can also type if add blue, and then on the next line blue, comma, and then if add red, red. And at the end of the program we can print colors2. And if we run the program now, we can see that we get the same output for both print statements. But I think we can agree that this code is more readable than this one. And as we read code from top to bottom, it is easier to see which colors are added to the list. And just to be clear, this is not a regular if statement. In fact, regular if statements cannot be evaluated or used inside a list of elements like this. Instead, this is called collection if, and you can use it to add a value to a collection only when a condition is true. Okay, so let me clear the old code. And I'm also going to rename this variable to colors, so that we can continue using this code on the next lesson. Now that we have talked about collection if, I'd like to show you a new feature called collection for. To do that, suppose that we have a new variable called extra colors equals, and then yellow and green. So how can we add these colors to this list? Well, if we wanted, we could add one more line before the print statement that says colors.add all with extra colors. So add all is a method that we can use to add the values inside the list to another list. And if we run this program, we get gray, brown, red, yellow, and green. So this code works, but if we want, we can accomplish the same thing using the collection for feature. So this is how it works. Over here, we can type for var color in extra colors. And on a new line, we can type color. And remember to add a comma, like this. And what this does is to iterate through all the values in this list and adds them to this collection on the fly. And this may not seem like a big improvement, since it was easy enough to add all the extra colors with just one line. But the advantage of doing things this way is that we can initialize the colors variable with this list literal in one go. And we don't need to add extra values after it has been declared. In any case, I'm about to show you one more Dart feature that makes writing this code even easier. So let's continue on the next lesson. In the last lesson, we have seen how we can add multiple values to a list with collection for. However, it would be nice if we could remove this loop and just type extra colors like this. Now, this code is valid, but look at what happens if we run the program. So something is wrong here, because the yellow and green colors have been added as a list object. But this is not right, and what we actually want is to take these items out of this list and insert them as separate items inside the parent list. To do that, we can use a special operator called a spread. And to use the spread, we need to type 3 dots like this before our list variable. And if we run the program now, we can see that all the colors are now listed correctly. So whenever you have a list variable or literal and you want to add its contents inside another list, you can use the spread operator. By the way, I should mention that collection if, collection for, and spreads are composable. So what do I mean by this? Well, over here I could add a new const add extra colors equals true. And then inside the list we can type if add extra colors. And this will only apply the spread operator and add the extra colors if this condition is true. By the way, the spread operator works not just with list variables, but with literals too. This means that we can copy this list literal from here and paste it here. And we don't need this variable. So as long as the expression to the right of the spread operator is a list, we can use it to add values to the parent list. In summary, we can use collection if, collection for, and spreads to more easily declare collections of values. And while this example program is very simple and doesn't do much, these features are very useful when we write Flutter apps. Because in Flutter we use a declarative syntax to specify how our UI looks like. So using these language features can really improve the style and readability of your code. Before we move on, I also want to mention that these features don't work only with lists, but with sets and maps as well. For example, here I can define this map that represents a restaurant with name and cuisine key value pairs, and I can also define a list of ratings like this, and I can include them in the map as a key value pair like this. And if I want, here I can use a collection if and type if ratings.len greater than 3. And as a result, this map will only have a ratings key value pair if there are more than 3 ratings. And if we want to add more than one key value pair, if this condition is true, then here we can add the spread operator followed by curly braces like this. And here we could type, for example, is popular and then give it a value of true, like this. Okay, so let's continue on the next lesson. In this exercise, we have a simple program that prepares a shopping list from a set of variables. So what I'd like you to do is to rewrite this program so that the shopping list variable is initialized using collection if, collection for, or spreads, and the program output is the same. As a reminder, you can find the source code for this program on the course GitHub repo at this location so that you don't need to copy everything by hand. Okay, so you can pause the video here and try to solve this. Okay, so let's do this together. As we said, we want to declare this variable only using collection if and collection for or the spread operator. To do this, we can add a new line inside these curly braces, and then we can move all these if statements and put them in here. And now we have some errors that we need to fix. As a first step, we can remove these curly braces because they are not needed with collection if. And then we don't want to use the subscript operator like this, but instead we just want to add a bananas key and use the bananas variable as the value. Then we can do the same thing with the next if statement. So again, we can remove the curly braces and change this line to become a key value pair, like this. Finally, we can update the last if statement and remove the curly braces. And because this grains variable is already a map, we can add it directly with the spread operator and type ... grains, like this. And as we can see, all the errors are now gone, so we can format this code. And as we can see, Dartpad has included each key value pair alongside the corresponding collection if statement in a single line. So it is perfectly fine to format the code like this, and in fact this is a lot more readable than what we had before. And now we can run the program, and as we can see, the output is the same as before. And I think that this example really shows how using collection if and the spread operator results in much more readable code. Okay, so let's continue on the next lesson. Now that we know how to use collections in Dart, I want to talk about a topic that sometimes can be a little bit confusing, and that is what happens when we copy a collection in Dart. To explain this, let me show you a simple example. Over here we have an empty program, and here we can type final list equals 1, 2, 3. So there's nothing special here, and all we are doing is to create a list literal that contains these values. Then we can type final copy 1 equals list. And then we can try to modify one of the items inside this list by typing copy 1 of index 0 equals 0. And then we can print the contents of these two variables. So here we can type print list is list and print copy 1 is copy 1 with string interpolation. And if we run this code now, we can see that list contains the values 0 to 3, and copy 1 also contains the values 0 to 3. Now, this may seem a little bit strange because we have set the element at index 0 for the copy 1 variable. So we would expect this variable to contain these values. But what's unexpected is that this variable also contains 0 as the first item. So what's going on here? To explain this behavior, let me show you a diagram. So what we have here is a grid that represents the memory in our system. And what happens when we create a new list literal is that some memory will be allocated and reserved to contain these values. And when we assign this to a variable, Dart will associate that variable with a reference to the location in memory that contains these values. And if we want, we can create more than one variable pointing to the same memory. For example, if we create a copy 1 variable and we assign it with the list variable, then both variables will point to the same location. As a result, if we modify an item using this syntax, then this will affect both variables because they point to the same location. And this explains the behavior that we see when we run this program. So the bottom line is that when we assign a collection like this, then we are not really making a copy of the values, but we are just creating a new reference to the same collection. So how do we make an actual copy? Well, one way of doing this would be to create a final copy to variable and assign it with an empty list. And then we can copy all the items one by one. To do this, we could use a regular for loop or even a collection for, so that we can add items like this. So this would work, but there is an even simpler way, because we can use the spread operator. So all we have to do is to type ... list, like this. By using this syntax, Dart will create a new list and will add all the values of this list inside it. As a result, here we can type copy 2 of index 2 equals 4, for example. And then we can print copy 2, like this. And if we run this program now, we can see that the first two lists have the same values, but the new list has 4 as the last value, which is different from this. And the reason this works is that here we are creating a new collection. As a result, Dart will allocate a new portion of memory and use it to make a real copy of whatever was inside this list. And because this list contains the values 0 to 3, then this list will also have the values 0 to 3. And if we modify the last item and give it a value of 4, then only this list will change, but not this one. In summary, we have just learned that in order to copy a list or collection, we can't just assign it to a new variable like this. But instead, we should use the spread operator, and this will guarantee that the original values are copied to a new location in memory. So I recommend that you experiment with this code and make some changes and see how they affect the console output. By the way, I should mention that there are also other ways of copying collections in Dart, but we are not ready to explore them just yet. And we will get back to this topic later on in the course, when we will talk about classes and learn about the difference between shallow and deep copy. Also, there are some common operators such as filter, map, and reduce, which are often used to transform collections, but we can't talk about them just yet, because we first need to introduce some more concepts. So for now, we have reached the end of this section about collections, and we can continue on the next section where we will see how to use them in practice with a practical project. This is the end of the 6th chapter. As a reminder, you can buy the full course on Udemy and get access to all the premium content that will not be included here on YouTube. So type this URL in your browser to buy my full course for a discounted price. Thank you very much for watching, and if you found this useful, please like and subscribe, and I'll see you on the next video.